Well, good morning. This is 11:31. I'm a minute late getting started on the 9th of April 2019. It's supposed to be linear algebra class, but right now I'm the only one in the room, so I'll go on and get started from here. We'll go from current slide and get the screencast-o-matic started. Wait a minute. I may have forgotten to... Oh no, I did start. So, okay, I'd already started the screencast-o-matic. Sorry. And we will, I'll go from the current slide then. Sorry, I'm sort of confused. I'll wait and do the announcements until some physical body come into the room, because I hate to make the announcements and then no one ever listen to them, so I'll wait until someone's here to hear it. All right. We're on, in Chapter 3, Determinants, 3.2, Determinants in Elementary Operations, and we're on page 117, Example 6, top of the page, Finding a Determinant. Okay? That's all we're interested in, the determinant. We're not trying to solve the matrix or anything else. We're looking for the determinant. So I'm just going to write this down as if it's a determinant. Okay, let me get my pen set up. If I can get the pen to set up. There we go. Right there. All right. So, the determinant of A, where A is the matrix defined by this. Here we have a 2, 0, 1, 3, negative 2. It should be a 5 by 5. If it's not a square matrix, you can't do a determinant. Negative 2, 1, 3, 2, negative 1, 1, 0, negative 1, 2, 3, 3, negative 1, 2, 4, negative 3, and the fifth row is 1, 1, 3, 2, 0. Okay, we're defined the determinant of that matrix however we choose to do it. All right? Now, frankly, the best bet to me looks to be to do something with the second column, because the second column already has 2 zeros in it and the rest of the numbers are pretty simple, so I'd say that's the one to go for. So let's hang on to row 2 and get zeros in 4 and 5. Okay? So what we'll do is, now, I'm looking at rows now, at columns now, so this is going to be a row reduction, and just want to see if there's anything real simple looking the other way. I don't see anything. So we'll do row 2 plus, actually before I do that, I'm going to do row 4 plus row 5 first, okay? Because that's simply an addition, and that'll eliminate that one, and then we'll go back and do row 2 plus row 4. We'll do that, but we'll do this one first, okay? So this will be the determinant. Now remember, when you do this, you add a multiple of one row to another row, you don't change the determinant at all. So that's usually a good thing to do. So let's do this. We're going to leave the top row alone, 2, 0, 1, 3, negative 2. We'll leave the second row alone. Negative 2, 1, 3, 2, negative 1. Okay? Then we'll leave the third row alone. 1, 0, negative 1, 2, 3. But first we're going to do the fifth row. We're going to add row 4 and row 5, and that gives me 4, 0, 5, 6, negative 3. All right, then we'll add row 2 to row 4. and that will give me a 1, a 0, add 2 to 4, my thing just flipped, 5, 6, and negative 4. Okay. Now, the determinant of that matrix there is, if you wipe out the first row, second row, second column, where that 1 is, and that 1 is in a positive position, plus, minus, plus, plus, minus, plus, it's a positive position on the diagonal, always a positive position, that would be the same as 1 times the determinant of what's left. So that would be the same as the determinant of 2, 1, 3, negative 2, 1, negative 1, 2, 3, 1, 5, 6, negative 4, and 4, 5, 6, negative 3. Not quite as nice a looking turnout as what we had before, okay? But it looks like, to me, just glancing at it, that column 1 is the one to use, and I'm just looking at other possibilities here, and it looks like that would be the easiest one to use. So I'm going to just arbitrarily go with the second row there. Pretty simple numbers. So we're going to use the second row to eliminate in the first column. Okay, we're going to eliminate the things in here. So the first thing I'm going to do is minus 2, row 2, plus row 1. Again, that doesn't change the determinant, so that's going to be the same as 0, b2 plus 1 is 3, minus 4, that would be a minus 1, and minus 6 minus 2 is minus 8. Okay, we'll leave the second row alone. 1, negative 1, 2, 3. Okay, and then here we'll do row 3 minus row 1. I mean row 2. Okay, row 3 minus row 2. You could have said minus row 2 plus row 3. I just found it easier to write that way. So that'll be a 0. That'll be a 6. That will be a 4. And that will be a negative 7. Okay? And then on the last one down here, we'll do minus 4 row 2 plus row 4. Okay? So that'll be a 0. Such a pain in the neck. Okay, that'll be a 4 plus 5 is 9. That would be a minus 8 plus 6 is minus 2. And that will be a minus 12 minus 3 is minus 15. Okay? So this will then be, now here's a minus 1 because this is in the negative position. So this is going to be minus 1 times the determinant we have left over. So we'll wipe out this row and this column. Okay? And that gives you a 3 minus 1 minus 8. Now I'm going to, now that I'm down to a 3 by 3, I'm going to repeat the first two columns. 3 minus 1. And this will be a 6, 4, negative 7, and a 6 and a 4. And this will be a 9, negative 2, negative 15, and a 9 and negative 2. Okay, now that's not quite a determinant, but you get what I'm doing here. So it's a minus 1 times, okay, the down diagonal here is a, ooh, goodness gracious, minus 12 times 15. is at 185. No, 180. Yeah. So that's a minus 180. Okay. And this will be a plus 63 because you got two minuses there. And this one will be a plus 12 times 8. Oh, let's do this way. 48 times 2 is 96. Yeah. Okay. Then let's do the up diagonals. And those will be a minus, which is plus. And that will be 72 times 4. That would be plus 8. Yuck! Such a pain in the neck. 288, I think. Okay. And then we'll do this one. That's going to be a minus. 6 times 7 is 42. And the last up diagonal is going to be a minus 15 times 6. I believe that's 90, isn't it? Yeah. All right. So let's add our positives together. I wish I had a calculator. 288 and 96 will be 384 and 63. 384 and 63 is 447. Okay, let's add our negatives together. 180 and 90 are 270 minus, that's a minus 270, and 42 is 312, I believe it is, and that's the negative. So subtract 312 from 447, and that gives us 135, and negate that, you get negative 135. Now that's a pretty big number. I'm suspicious. Let's see if that's what they got. Yes, look at that, negative 135. Okay? Now I'm sure they did it differently, and that's perfectly okay to do it differently. Okay? Okay. So they, yeah. Yeah. However you get there, I don't think ours is any harder nor easier than theirs. Maybe theirs was a little easier and ours was a little harder. So that's what you got. And that then, folks, finished 3.2. Okay? And you see, a 5 by 5 is not that bad, especially since the numbers are pretty simple and you can eliminate things pretty easily. All right, 3.2 homework exercises. Do any of the odds, 1 through 19. These are all located at calcchat.com for worked out solutions to the odd number exercises. Okay. Now, what I would do, I'd do them first, check the answers in the back, because the odd number have the answers in the back. If you get the right answer, you don't need to go to CalcChat, unless you just want to see if they do it a different way. But if you can't get the answer in the back, you don't see how to get it, then go to calcchat.com and you can see how they do them. Okay? Then do either 21 or 23. They're both at CalcChat. Any of the odds, 25 to 35, they're all at CalcChat. There's a true-false 37. It should be at Calc Chat. Then you can do either 39 or 41. They're both at Calc Chat. There's a proof at 43. You can do that if you choose. 45 should be something fairly easy to do. And then 47 is another proof if you choose to do it. You don't have to do the proofs, but whatever. All right, now let's move on to 3.3, which is properties of determinants. Okay, so let's clear the slide here. Okay, and let's go to properties of determinants. Page 120, 3.3. Okay, there's three keys we're going to try to do. The first of these is matrix, products, and scalar multiples. In this section, you'll learn several important properties of determinants. We'll begin by considering the determinants of a product of two matrices. So here's what we've got. We need to determine what the determinant of matrix A is, and I'm going to go straight to the determinant. The determinant of A is going to be the determinant of 1, negative 2, 2, 0, 3, 2, and 1, 0, 1. All right, I hope I did it right. Now, you have a couple ways to proceed here. If you could just eliminate this 1 down here, you can make it a triangular matrix, which would then be real easy to do the determinant. It's just a product of the diagonal. And that would be an easy thing to do. No, it won't. Okay. Because once you start messing with this, then you're going to mess with that. So I would expand it the way we usually do 3 by 3s. Repeat the first two rows. 1, negative 2, 0, 3, and 1, 0. Okay? Do our diagonals, and this will be 3. This will be minus 4, and this will be 0. Up diagonals, minus 6, 0, 0. So this will be minus 7. That's the determinant of A. Let's do the determinant of B. You see, if it was easy to do row reduction, it's also going to be easy to do your expanded on the 3 by 3s. Okay? So let's do determinant of B. I won't write down B except in its determinant form, just saving some space. 2, 0, 1. And I'm going to expand it, 2, 0, okay. 0, negative 1, negative 2. 0, negative 1. And 3, 1, negative 2. 3, 1, negative 2. And a 3, 1. Okay. And let's find its determinant. That's going to be a 4. It's going to be a 0, and that's going to be a 0. Then your up diagonals is going to be a plus 3, because it's a minus. Up diagonal there is plus 4, and up diagonal there is 0, so this is going to be 11. All right. Good so far. Now, what we need to do now is multiply the two matrices and then take the determinant of them. So AB, the product of AB, is going to be, A is a 3 by 3, forget these, and B is a 3 by 3, forget those. I'll get rid of the construction lines. This, and that, 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 and that. Yuck. Okay. So let's just multiply these two matrices together. All right. It's going to be a 3 by 3 because 3 by 3 times 3 by 3 is 3 by 3. Notice the sound effects. Okay. Now, first entry is 1, 1, so it's first row, first column. That would be 2, 0, 6. 2 and 6 is 8. Okay? First row, second column, 0, 2, minus 2, that's 0. First row, third column, 1, plus 4 is 5, minus 4 is 1. Okay? 2, 1 entry, second row, first column, 0, 0, 6. Second row, second column, 0, negative 3, plus 2 is negative 1. 2, 3 entry is second row, third column, 0, negative 6, minus 4 is negative 10. Okay? The 3, 1 entry is third row, first column, 2, 0, 3 is 5. Okay? 0, 0, 1, and 1, 0, negative 2. So it'll be a negative 1. Okay? There's the product of those two matrices. Now let's look at the determinant of that product. That's what we're really after here. So we will, I'm going to take away these lines here because they're just a little cluttering. And we need all the room we can get and all the clarity we can get. So we're going to do a determinant here, which is just expanding the first two columns, 8, 0, 6, negative 1, and 5, 1. Okay, and we'll do our down diagonals, and that's going to be 8 plus 0 plus 6. Up diagonals are plus 5 plus 80, 0. Okay. Ooh, what does this come up being? 88 and 11 is 99. That doesn't look good. I think I messed something up here. Positive. Ha! No, 0. Positive. 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 0. I must have messed a sign up in my adding. Let me check that AB is, they got a 4 where I have a 0. Let me, okay, let's go back. Alright. Need to go back and check my multiplication. I was doing it fast. So let's go back and check. Okay. 2, 0, 0, and 6 is 8. Got that. Then we get a 0, 2, minus 2. I get a 0. So I must have copied something wrong. 1, negative 2, 2, 2, 0, 1. 0, 3, 2, 0, negative 1, negative 2. 1, 0, 1, 3, 1, negative 2. Okay, and try it again. 2, 0, 6, that's 8. 0, 2, minus 2, that's 0. How did they get a 4 there? Let me do their numbers. 2, 0, 6, that's 8. 0, 2, oh! Alright, let me try it again. 2, 0, 6, that's 8. 0, 2, 2 and 2 is 4. Goodness gracious. I hope that's the only mistake I made. we'll see. Okay, now we'll expand this. 8, 4, 6, negative 1, 5, 1. Okay, now we'll do our expansion. This will be an 8. This will be a, minus 200. I'm going to check my numbers here. Now that looks okay. Okay, and plus 6. Okay, then do the up diagonals here. That's going to be plus 5. And this will be a plus 80. And this will be a plus 24. All right, let's see what we get. I have 1 minus and the rest pluses. These two added together give you a 104. Add 8 to that, you get 112. Add 11 to that, you get 1. I need to write it down. Okay, 104 and 8 is 112 and 11 is 123. Minus 200, yep, that gives you negative 77. Well, guess what? If you multiply the determinant of the first times the determinant of the second, you get a negative 77, and the determinant of the products is negative 77. So at least the inference here is that when you're multiplying two matrices, it says it's true in general, okay, that if, I think I'll, let's see, I think I can fit it in here. If A and B are square matrices, okay, of order n, okay, now that means they have to have the same dimensions. 4 by 4, both of them 4 by 4s, both of them 7 by 7, both of them 3 by 3s, whatever. They have to be the same dimension. Then, if that's true, then the determinant of A times the determinant of B is equal to the determinant of the product of A and B. Interesting and true, okay? They did it the other way. The determinant of AB is the determinant of A times the determinant of B. It doesn't matter which way you do it. Okay. Now, I'm going to have to go to, I'm choosing to go to a clean page now because that would be awfully crowded to write it there. So let's go down here. Here's the next theorem. The determinant of a scalar multiple of a matrix. So what we have is A is a square matrix, and I think they'll say of order n. In other words, it's an n by n matrix. Okay, and C is a scalar. Okay, then the determinant of CA is equal to, all right, now get this one, it's C to the n times the determinant of A. C to the n times the determinant of A. Now why is that? Well, CA, that C is going to multiply by every element in A. So let's just imagine A was an identity matrix. So now that new matrix will be C00, 0C0, 00C, you know, or whatever. You're multiplying by every element in there. What you do to the determinant of that now, you would have to have C times your expansions, however you do the expansion, but you have n rows or n columns, so depending on how you're expanding, you're using C n times because it's multiplied by every element in there, every element in every row, or every element in every column. So that would be C to the n times the determinant of A. Okay. Let's do example 2. I think we've got room to it now. Here's what we got. A is equal to this matrix. I'll write it down. 10, negative 20, 40. 30, 0, 50. And negative 20, negative 30, 10. Okay. Now, if you notice, every element is there as a multiple of 10. So what you can do is pull out a 10. Okay? And that would be 10 times 1, negative 2, 4, 3, 0, 5, negative 20, negative 30. I'm sorry, negative 2, negative 3. I don't know where my brain went there. It just spaced out. Negative 2, negative 3, 1. Okay. Now, if you want to find the determinant of A, the determinant of A would then be, according to this thing here, it would be 10 raised to the third power, because that's a 3 by 3 matrix, order 3. And then times the determinant of what you got left. Well, again, it's a 3 by 3, so I think the easy way to do those is 1, negative 2, 4, 1, negative 2, 3, 0, 5, 3, 0, and negative 2, negative 3, 1, negative 2, negative 3. Okay? And then do your diagonals. Well, this one would be 0. This one would be 20. So it's 10 cubed times 20 minus 9 times 4 is 36. Then doing the up diagonals, that's going to be a 0. That one's going to be a plus 15. And this will be a plus 6. So it'd be 10 to the third times 20 and 15 is 35 minus 36 would be a minus 5 plus 6 is 5. So this will be 5,000. That would be the determinant of that original 1. And sure enough, that's what it is. Okay. Okay. It seems like this time of morning my head clogs up. I don't know why. The room is a little on the cool side, but I don't know. It just is a little bizarre. Let's see if I can make it through. We started at, we got till 12:15, so we've got about 35 to 40 minutes. So we're barely halfway through. Let's see if I can keep talking without getting something to drink. We'll give it a shot. Okay. Because even if nobody's here, I've got to make some announcements. So I'll need to wait till near the end and make announcements even if nobody's here. Nobody other than me. Okay. So theorem 3.5 and 3.6 is forms of the determinants of the product of two matrices and a scalar multiple of the matrix. These theorems do not, however, give a formula for the determinant of the sum of two matrices. The sum of the determinants of two matrices usually does not equal the determinant of their sum. That is, in general, determinant of A plus the determinant of B is not equal to the determinant of A plus B. So I hope you wouldn't expect it to be that, because a lot of these operations, sums don't work as well as products do. But just a really quick example, if this is A, 62, really simple, 6221, and here's B, 3, 7, 0, negative 1. Okay, and the determinant of A is equal to 6 minus 4 is 2. Determinant of B is equal to minus 3. Okay, minus 0 is 0, is minus 3. Okay, then A plus B, very simple to do here. That would be 9, 9, 2, 0. The determinant of A plus B would be minus 18, which has no relationship at all with the sum of 2 and negative 3. Just nothing. Okay? 2, negative 3, negative 18. There's nothing to deal with that. Okay. Now, let's now look at determinants in the inverse of a matrix. Okay? All right. I think that might be, this is the place I need to stop. Pause right now and see if I can go clear my throat, my head, and get a little something to drink because my voice is getting too raspy. Hold on. Well, I'm back. A little bit clearer, but not a lot. I've sort of figured out probably what one of the problems is. When there's students in the room, I don't do as much talking. I ask questions, but then I have a lot of pauses and stuff and waiting for students to answer, and I interact, but I'm not doing as much talking. When there's no students in the room, I'm talking nonstop, and it just, I think, wears on the whole system, and that's probably what part of it is. I don't know. Anyway, let's go. Top of page 122. Determinants in the inverse of a matrix. Okay? They start with, it can be difficult to tell simply by inspection whether or not a matrix has an inverse. Okay? And they say, can you tell which of the following two matrices is invertible? Here's matrix A. Okay? 0, 2, negative 1. 3, negative 2, 1. And 3, 2, negative 1. Okay, that's matrix A. Here's matrix B. 0, 2, negative 1. 3, negative 2, 1. And 3, 2, 1. Okay. Now, it just says, can you tell which of the following of these two matrices is invertible? Now, frankly, they could both be invertible, and they could both be non-invertible, or one could be invertible or not. They suggest in the one. Well, I'll tell you something. Okay, just looking at the two matrices, if you look at these two columns here, the second column and the third column of the matrix A, you see they're a multiple of each other. The second column is minus 2 times the third column. And anytime you have either two rows or two columns that are a multiple of each other, that's not invertible. So this one would be not invertible. Okay? Non-invertible. So you can't tell looking at B whether it is or not. It's just not as obvious that it's not, but that still doesn't mean that it is invertible. Okay? And that leads to theorem 3.7. And here's what it says. A square matrix A is invertible which also means non-singular. One's a positive word, one's a negative word. If and only if the determinant is not equal to 0. If, let me do it this way. If and only if the determinant of A is not equal to 0. If the determinant of 0, it is not invertible. Okay? Now, there's a little discovery here on the side. And it says, let's get the determinant of this A. I mean, not the determinant, we are, but I think I'm going to clear this out of the way because this is leading to what we're going to do next. Okay? So let's first erase this, and here is matrix A. Is 6, 4, 1. I said 6, 4, 1 and right 4, 6, 1. Okay. Nope. Wrong. Wrong. Okay. Okay, that's the one I meant to hit. Okay. 6, 4, 1, 0, 2, 3, and 1, 1, 2. Okay. We want to find its inverse. So we're going to augment that with 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? And we're going to do row reduction with that. Okay? Well, first, we're going to flip these two rows. Okay? Because I want the 1 in the upper left. So this would be equivalent to 1, 1, 2, 0, 0, 1, 0, 2, 3, 0, 1, 0, and 6, 4, 1, 1, 0, 0. Okay. Next, I want that 6 to become a 0, so this will be minus 6, row 1, plus row 3. Okay. So the next matrix, I'm going to use row 1, so that stays the same. 1, 1, 2, 0, 0, 1, 0, 2, 3, that stays the same, 0, 1, 0, and when you multiply minus 6 times row 1 and add it to row 3, sorry, my throat's messing up again, that'll give you a 0. It'll be minus 6 plus 4 is minus 2, and minus 12 plus 1 is minus 11, and 1, and 0, and minus 6. Okay. All right. What we want to happen next is for, ooh, man, what a mess. I think it'll be easier just to, okay. Again, first thing I'm going to do is add row 2 and row 3 to give you a new row 3, and then I'll come back and divide row 2 by 2. Okay, so let's first add. So that is going to produce 1, 1, 2, 0, 0, 1. I'm going to hold off on that for a minute and do 0, 0, negative 8, 1, 1, negative 6. Okay, now I'm going to divide row 2 by 2. So it'll be a 1, 3 halves, 0, 1 half, and 0. Alright. Boy, what a pain in the neck this is. Alright. No wonder they said use some other package to do this. I'll try to squeeze it in here. Next thing I'm going to do is divide the third row by negative 8. Okay. So that's going to make a 0, 0, 1, minus 1/8, minus 1/8, positive 3/4. Okay. Ugh. Okay. Now I'm going to take that and multiply for the top minus 2 times row 3 plus row 1. Okay. So that will be a 1. Oh, wait. I'm sorry. Yuck. I left something out. Okay. That will be okay, but what I left out, I forgot to change this 1. So minus row 2 plus row 1. Okay. So in other words, subtracting row 2 from row 1. Row 2 minus row 1 minus row 2. That would be a 1, a 0, a 1/2. Well, good to see somebody here.
I wasn't expecting to be the first one.
Yeah. Just realized I hadn't filled in the book here.
Is there a free printer on this campus, or is everything you have to pay for?
Free printer?
Yeah.
I don't know the answer to that. Well, I sort of do know one. What do you need to print?
My unofficial transcript.
I can print it for you.
Okay. Thank you.
All right, let's get down and get Vince here. Okay. We have a student. Yay. Okay. I'm going to pause what I'm doing on this. So I'm going to turn on my projector. No one in the room. I'll save on the bulb. I'll eat a snack.
Yes.
And I'll stop right now and go over announcements because there are some important ones out here. Okay. I've done this one already, but just to make sure you've heard it. Are you ever on the Birmingham campus?
You said, am I?
Yeah.
Like at all today?
Yeah. Well, no, anytime.
Only time I'll be over there is on Thursday.
On Thursday.
For the thing, like for the awards thing. You know, on the class I got.
Oh, I see.
Yeah, for Mary, Algebra, and Catherine.
Okay. Well, what I was saying, if you're familiar with the Birmingham campus, the old Student Center, Leon Kennedy building, fairly, I mean, you can tell it had a few years on it, but it was a fairly modern looking building, better than the classroom buildings were.
Yeah, it was newer.
But it's closed now.
Are they closed?
Yeah, everything is moved to this new building. They've been doing.
Oh, that one that's like across that they just opened up recently?
Yeah,
okay.
Yeah, exactly. Now they sort of opened two recently. This is the only one officially open. They did open, or working on a new dorm, but that's not been open yet. This is right on Wilson Road, but it's still on the west campus. So everything that was in Leon Kennedy is now in this new building. Of course, this new building is probably 2 or 3 times the size of Leon Kennedy, so there's a lot of empty room in there. And here is Daniel. So they're coming by swarms now. Okay. So that's the cafeteria, the Space Center, the bookstore, the police department, everything that was in, all the counseling and everything that was in Leon Kennedy is now over in the new building that's called the Academic Success Center. Okay? And I also wanted to say to you, like announced before, the NCAS, that's NASA's Community College Aerospace Scholars Program, is taking applications now and will be doing so through May 15th for next year. The program doesn't start till next fall, but you got to get your application in before May 15th. Okay. I think I've already announced that, and I'll leave that alone for now. Okay. Now here's something else, and I don't know if y'all are interested or not. You may be. You have on a Tuskegee shirt, but you may be interested in this. Yesterday morning on the Birmingham West Campus in the new Academic Success Center building, there was a special signing ceremony between Alabama State University Transfer Memorandum of Understanding. Our president and their president were both there, and I don't know exactly all that it means, but what it connotes to me is it now just got a lot easier to go from Lawson to Alabama State. There must be some program in place. It's just about seamless, okay? I don't know all the details, but they did the special signing yesterday, so that should be in place now. And then, I don't guess either of you are interested, but if you're thinking you might be the next Miss Lawson State, okay, there is a thing this morning. It's already going on now. In fact, it's been going on for about an hour, and it goes until 1 o'clock, so it doesn't go much longer, another 30 minutes or so. It's called the Interest Forums, and that's here on this campus in room 182, which I think is the testing center down there. Requirements: you must be currently enrolled at Lawson State Community College, 3.0 grade point, cumulative grade point average, completed or currently enrolled in a minimum of 16 credit hours at the 100 level or higher, and active in an extracurricular activity or organization. For more information, Ms. Leslie Harper and Ms. Janine Jones are both on the Birmingham West Campus in the new Academic Success Center, and Ms. Kimberly Moore her office is right across from the testing room down there in room, I don't know her room number, but it's right across from 182. Okay? So if you or someone you know is interested in that, let me know. Now here are the biggies, okay? First and foremost, tomorrow, all of the full-time instructors at the college, except for the nursing faculty, the allied health, that's nursing and dental and anything to do with health, all the rest of the faculty has to go to Montgomery. We'll be leaving by 7:30 in the morning, and we won't be returning until probably something around the order of 5:15. Could be a little later, maybe a little earlier, but more likely a little later, okay? So we will not be on campus at all tomorrow. So therefore, and were you here yesterday's class? So I told you what to do for tomorrow. Before today's class is over, I'll tell you what to do for Thursday, college students. That's coming up too. Okay, now, this is an enormous boondoggle. You said you didn't have any two classes with my two, so I won't be here for any class tomorrow. And you don't have, Daniel might, or other people listening might. If you have an adjunct instructor for a class tomorrow, those classes are meeting. So be in class tomorrow unless you have a full-time instructor. And make sure you understand from the full-time instructor that you're not having class. There may be a couple that for some reason or another, like they have mini-term classes or something and can't afford to miss a class. I think everybody else has to be there. Okay. So that's tomorrow. What a waste of time.
Oh, surveys are out already too?
Okay, I didn't know that, but is that just come out today?
It's on my email, yeah.
Okay, all right, well then start doing your surveys. Just got that. Student course evaluations have been open now, so you can wrap those up for, you can do spring terms student course evaluation. Okay. Now, here's the next thing. On Thursday is Honors and Awards Day. Now that's over on the Birmingham West Campus in the Arthur Shores Fine Arts Building, which is also our gymnasium. Fine Arts and gymnasium, I guess that goes together. And then the program is 10 till 12, my understanding. Okay? Now, what that means though is that classes will be canceled, and they say all classes will be canceled from 9 till 12:30. So that means if you have an 8:30 class tomorrow morning, you'll probably only meet for 30 minutes. I'll be meeting with my 8:30 class, not tomorrow morning, Thursday morning, for 30 minutes only. Okay, and then I'll tell them what to do for the rest of the period. Okay, to make up that. okay? If you have a 10 o'clock class, that's gone completely. My trig class, today was the last day we meet this week, okay? 11:30 class, you will not meet until 12:30, which is the last 15 minutes, so I imagine most of them will not meet at all, okay? And that would be this class. This class is a 11:30 class, so I'll be here as soon as I can get back here, but if no students are here, what I'll do is give you an assignment today for what to do for Thursday, okay? And then I'll be on campus as soon as I can be. If you have any questions, come by and see me, but it'll probably be 12:30 or later. Oh my goodness, looky here. Jordan's here.
You gave test 3?
Okay.
That's test 1.
There's test 1.
Yeah, I got others I'm working on.
Okay.
I got
Okay.
my differential equation 1 too.
Okay.
I still got a couple more to do.
Okay. Well, then you need the second test in this one. Is that right?
I got second.
Oh, you got it. Okay.
You got another one in calculus 3?
This is test 1?
Yeah.
Yeah, I have given a test 2. So I don't have it up here with me, but right after class I'll go get it. Okay. All right. So I was just saying, and it's good you came in to hear it. If you have classes tomorrow between 8 and 5, okay, I'll put it that way, which is all day long, with a full-time instructor like me, those classes are not meeting tomorrow, okay? I've already given the assignments. You'll have to go to YouTube and see the last class and see what I said to cover to cover tomorrow's class, okay? We have been forced to go down to Montgomery for a special meeting with the chancellor. All full-time instructors except nursing, the allied health program. So we are stuck, okay? We can't avoid it. We can't miss it. So if you have an adjunct instructor for tomorrow, those classes are still meeting, okay? But full-time instructors, those classes are not. Then on Thursday, between 9 and 12:30, classes are canceled. All classes, full-time or adjunct, are canceled because they're having honors and awards over on the Birmingham West Campus in the gym, the Arthur Shores Fine Arts Building. The ceremony is 10 to 12, but because people have to be there early, they require us to be there by 9:30, meaning I have to leave campus here by 9 in order to get there by 9:30 to stand around and wait for 30 minutes until the program starts. So classes between 9 and 12:30 are canceled. This class is 11:30 to 12:45, so that just leaves 15 minutes of class. There's really not a reason to come here for 15 minutes of class. So at the end of class today, which is coming up pretty soon now, I will be assigning what to watch on YouTube videos for Thursday's class, okay? And then if you have questions, I'll be here sometime around 12:30. Maybe a little before, maybe a little after, but you can catch me sometime then if you have any questions, okay? All right. Now, let's get back to this now, okay? Yeah. Was that all the announcement? There was one more, I think. Okay. Get this where it belongs. Okay. So those are the next 2 days, almost wasted. Okay. They came out with a final exam schedule. I think y'all were copied on this. The trouble is, it's wrong. Okay. Or they have the calendar wrong. I don't know which it is. I think the calendar is right because that had to be approved by the chancellor's office. So I think this is wrong. They have final exams starting on Monday the 29th, but the calendar says they start on Tuesday the 30th. And they go through Monday the 6th. This shows them ending Saturday the 4th. So I'm pretty sure this is wrong. How they're going to correct it, I don't know. So you'll have to wait and see on that. Okay? They also have listed here, and this is more for us than for you, All grades for mini-term 2 and regular term students must be inputted into WebSeat system. That's what we do. No later than 12 noon on Monday, May the 8th. Well, that's hogwash because Monday is the 6th. Okay, so we can't do it Monday the 8th because it's not Monday the 8th. But on page 3, it says Wednesday, May 8th. That's correct. The one on this page is wrong. So, sorry about that. All right. I think that covers most of what you need to know there. So let's get back to this. What we're doing is finding the inverse of matrix A. So I set up the, adjoined that with the identity matrix, and I started through the process, and it got really messy right about here. But before it got messy, well, it is a little messy, and you'll have to go back and listen. I'll explain what I do. Before I eliminate that 0, I'm going to, I'm sorry. Before I eliminate these 2, I'm going to eliminate that, and I do it by row 2 minus row 2 plus row 1. In other words, row 1 minus row 2. And I did the first 2, 1, 0, and 2 minus 3/2 is 1/2. That's where I was. Let's continue from there. How much time do we have? I've wasted so much time here. Yuck. We only have a few minutes. Let's see if we can get this done. Okay, 0 minus 0 is 0. And 0 minus 1/2 is negative 1/2. And 1 minus 0 is 1. All right. Now what we're going to do is, okay, and here's what also I did. The third row wound up this, so I divided by negative 1/8. So that, or divided by negative 8. So that made this a 1, this a negative 1/8, negative 1/8, and positive 3/4. Okay? So now I'm going to use that one. Goodness, they keep coming. Good to see you. Oh, all right. Mohammed's here. We have more than half the class here. This is a miracle. Okay. Just getting sort of. Okay. And we are, well, we have a little time. So let's see if I can finish this. All right. So this is the new row 3. Okay. I divided the previous row 3 divided by negative 8. Okay. And that's how I got that one. Okay. Now I'm going to use this one here to change this to make that a 0, to make that a 0. So here's what we're going to do, not to confuse these. So negative 2 row 3 plus row 1. Okay, that's what we'll do first. No, sorry about this. Wait. Yeah, I'm sorry. Let's change this. Okay. I'm sorry, I realized I've already changed row 1 once. I need to be doing the new row 1. So what we're going to do is minus 2 row 3 plus, no. Change that again, sorry. I'm not going to get this done before the end of the period. Okay, let's try it one more time. Negative, because here's the new row 1, not this one, this row 1, okay? We'll do negative 1/2 row 3 plus row 1, and that'll be the new row 1. So that becomes, I need a new bracket down here, okay? I should have just filled in this. Let me just do that. 0, 1, 3/2, 0, 1/2, 0. And this will be 0, 0, 1, minus 1/8, minus 1/8, 3/4. Okay. Now, this thing happens right here. Negative 1/2 row 3 plus row 1. Okay. So this becomes a 1, 0, 0. Okay. Negative 1/2 times negative 1/8 is negative 1/16 plus 0 is negative 1/16. And negative 1/2 of wait a minute. That's positive 1/16. Negative 1/2 times negative 1/8 is positive 1/16 plus 0 is positive 1/16. Negative 1/2 times negative 1/8 is positive 1/16 minus 4/16. That would be minus 3/16. And then negative 1/2 of 3/4 would be negative 3/8 plus 8/8 is 5/8. All right. Sorry about that. All right. Now, our next thing is minus 3/2 row 3 plus row 2. That will get rid of that one. So that gives you a 0, a 1, and this will be a 0, and this will be a minus 3/2 times minus 1/8 would be a minus 3/16. No, positive 3/16. Minus times minus is positive. And minus 3/2 times minus 1/8 is positive 3/16 plus 4/16 is 7/16. Okay? And then the last one is minus 3/2 times 3/4 is minus 9/8. Okay? And then the last one is 0, 0, 1, 1, negative. No. I got off. Okay. All right. I'll get it in a second. Negative 1/8, negative 1/8, 3/4. All right. So this is, according to my doing, the inverse of the original matrix. I see now why they said use a package to do it, because this was a pain in the neck to do. But we got it. Okay? Now, I'm going to clean that up a little bit by pulling out a 1/16. Is that okay? So if I pull out a 1/16, then this leaves me 1 minus 3, 10. 3, 7 minus 18. Minus 2, minus 2, is that 12? I believe that's right. Yeah, that would be 3/4, right? Okay. I believe that's right now. Okay. Now, the next thing it said to do, and I'm afraid we are out of time. Okay, you can finish the discovery on the side there, and that's on page 122, and we'll start next time with example 3. The reason I have to stop here is I need to tell you what to do next. So we went from 3.2 to 3.3. So I'm going to get out of here. No, that's not what I want to do. Let's do this. Throw that away. That I'm still recording. I want to get rid of that if it'll get rid of it. And go to Blackboard. Hopefully y'all are used to doing this, going to Blackboard. Okay, I'll show you what you're going to do in Blackboard, if it'll ever come up. It's been awfully slow today, so I wonder if everybody's doing this. Very, very slow. Yeah. Okay, here it is. Again, it's awfully slow. Sorry about this, folks. I didn't know Blackboard was going to be this slow. Waiting for Blackboard. Sometimes when it's this slow, then it doesn't recognize the password because I think the time runs out. Let's hope it recognizes the password. Come on, folks. All right, it looks like it's going to get there. Maybe. It's not waiting for it anymore, but it's not doing anything. All right, please, folks. Blackboard Learn. It's so stinking slow. And watch it come up and say I've timed out on it. Nope. Nope. All right. Now, I think probably for y'all, I don't know how your side looks. This is how the instructor side looks. This one sometimes takes forever to come up, so I'm going to use this block over here, which, okay, we'll go down and find Math 238. Okay. This is, whoa. Where is my class? There's spring 16, 17, 17, 18. Oh, I'm in the wrong class, sorry. This is 237. Okay, here we go. Spring 18, 19. There we are. Sorry about that. But still, my 238 class isn't showing up, which is not very encouraging. Okay. I think it'll open one of these days. Here we go. All right. Now, I know y'all are familiar with this. The syllabus is located here. My locator card is located there. Just about everything else is here. Handout, PowerPoints, and more. We don't have any PowerPoints. So basically, this is going to be a few websites and the YouTube videos. Hopefully, it'll come up today, sometime, soon. This is incredibly slow. I don't know where it is. Here we go. There's the YouTube videos. Okay, there's the research paper instructions and then two websites. Here's the YouTube videos. Click on that. Now this usually doesn't take too, here they are. Okay, these first, we are not in chapter 4 or 5 yet, so don't worry with those. We're in chapter 3, and today we did 3.2 to 3.3. So here's what you do next time. Now, I don't know why these two have the same names, 3.3 to 3.4. I don't want to delete either one of them. I have a feeling this is 2.2 to 3.2 to 3.3. If that's that, then do this one. You know, whatever. But anyway, these two are the ones you do, 3.3 to 3.4. I don't know why there's two of them out there, but there are. So do those two, and then I think probably it's just going to be the second one. I think I'll check and see. I may delete 14 because that may be wrong. That's what you do for next time. Today's is 3.2 to 3.3, which is what we just finished, and then we'll do this one. So I'll probably delete the first one. All right. Go and watch those, and we'll pick up with 3.4 then next time. Okay? Make sense? All right. Then I'm going to end this, end that, and end this.